In this lecture, we learn about generics. Let's see what the learning objectives are upon finishing this lecture. We will hope that you are able to understand two aspects. Number one is from the supplier's perspective, you will know how to write a generic class for other people to use. And as a client, given that some suppliers actually implement a generic class, how can you use it? We want to see from these two perspectives. Later on, we're going to revisit this particular topic about generics. Once we talk about inheritance and also typecasting, we'll see this topic in more depth. But for this particular lecture, let's now consider a motivating example. So why do we need to write or use a generic class? Let's say we have a very familiar data structure for you. Let's call it stack, last in, first out stack. First of all, let's start with, let's say every element we store in the stack will be a string value, reference type. Could be integer as well. Let's say a string. And then the none over here, you can say feature section here. And now you want to get used to having this particular decoration here. It's called export status. We'll talk a little bit more about this later on when we need to play with it. But now every time you see none, it's as if you declare some attributes or all the features under this particular section they are simply just private. So they are not visible to any external clients using this class. Okay, so none over here is simply just private. So let's say we have a private implementation here called imp of type array of string over here. Okay, so that's what we start with. And then we also have some attribute I of type integer. So that would be just to mark where the end of the stack is. And then we have another feature section here. You can see now we don't have the exported to none over here. So this feature here, every feature under this particular section here will be public. So now you want to distinguish between this section over here being private and also this section over here being public. Okay, it's very easy distinction. So now let's say we have one query over here. So count will just return the counter value I. So I shouldn't really bother you too much about this particular implementation strategy. You should have known how to use an array to implement a stack. Okay, so I would be just like at the end of the stack that also correspond to the size of the stack. So we assume the array indices start with 1. So we have also the top, so that will simply return the last elements of the stack. And we also have the normal command for the stack, which will be to push to the top of the stack. So we simply got the input parameter of type string, and then we simply just change the top of the stack to be v, and also we increment the counter, right? And then we say again we want to do pop. So you can see in this case the pop is also another command, but it takes no input parameter, and we don't really put any parentheses, right? Syntactically we are forbidden to in this language. And then we simply decrement the counter. Again, I denotes the top of the stack. Okay, so that's about a very simple class over here. So now let me ask you this particular question, which you may not have thought about. Okay, so now does how we implement this particular string stack, so there's a typo here, it should be a string stack. Okay, does how we implement this string stack operation, for example, top, push, and pop. So you can consider the top, the push, and the pop. Does how we implement these three commands or queries depend on the type of the element string over here. For example, does it really matter? So now we are only storing every element being a string. What if we change that to be, for example, let's say stack of integer was stack of account was stack of birthday, and etc. Does the last in first out retrieval or pushing mechanism really get affected by the type of the element that's stored in the stack? Does it or does it not? You can pause the video and tell me. Okay, so now assuming that you have thought about it, the answer is no. The type of the elements is basically an independent or orthogonal aspects for this particular class. So you can think about there are two aspects for this particular class over here. Number one, it's about the last in, first out. So just about how we actually implement the top, the push, and pop. So these are just the last in, first out for any clients of the stack to insert or delete elements in or from the to or from the stack. The second aspect is really about what elements can we store in the stack. It could be different types. The types could be string, or it could be account, or it could be anything. So these are two orthogonal or independent aspects which we should handle differently. Okay, so now here's the thing. To really let you see more in a more obvious way why this particular design is actually pretty poor, because every time you think about design, think about how you can scale it up to different types or different needs in the future. So now in this case, let's say how would you implement another class? Let's say another we also want a stack, but now this time we want to store a stack of accounts. So now every element, rather than being a string, is going to be an account object. The question is, are we going to have a very different class or a very similar class? If you believe it's going to be a very different class, how different are they? And if you believe it's going to be a very similar class, how similar are they? Okay, again, you may want to pause the video a few seconds and think about it. Okay, let's now see. Basically, as I said before, there are two aspects. One is about the last in, first out retrieval and also storage mechanism. And the second aspect is really about the type of elements. So now we are only changing the second aspects, which is about the type of elements. But the first aspect is stay the same. So that means for that particular first aspect, we still have to duplicate them basically in a different class. So that's how it's going to look like. And if you notice how I actually highlight the name of the class and certain elements in the class, you will see exactly why I'm highlighting them this way. Let's say for this second class, first of all, we still have this private implementation attributes over here, just still an array. But now every element in the array, by the way, array is just another generic class, which is exactly what we're talking about here. But you can now just think about from tutorial lab 0, we learned about how you can declare type of the array. So now rather than string, it's just an account. And then we also have this counter here. So this part here is actually for the first aspects about the last in, first out storage retrieval mechanism. Okay, we got the same count. That's the same as before. So now you can think about we are duplicating this block of code from one class to another, right? And then we also got top. This part over here is about the last in, first out. So where is the top of the stack? So this part also is duplicated. The only difference is now the return type is actually account as opposed to string. And then we do another one. So let's say push. So exactly the same as before. The only difference is, so now the input parameter type has changed from string into account. And also we got a pop. Okay, the same as before. So now you can see just by this simple scenario over here. So let's say for our design, when you go from the previous slide to this slides, we're basically trying to handle two stacks over here, stack of account and also stack of string. But they look so similar. And that means we are duplicating a lot of code over here. So every time you see a lot of duplication, it's a very strong sign about poor design, which I will explain. So now let's say, okay, again, the same question. Does how we implement the, again, it's a typo here. It shouldn't be integer, it should be account. Does how we implement account stack operations, top, push, and pop, depends on features specific to the element type. In this case, just account, right? Again, the answer will be just the same as before, simply no. Again, there are two aspects as I talked about. One is about last in, first out. The other one is about the element type. So these two aspects are completely orthogonal. You should really consider them independently. Okay, so now we want to know this. A collection, basically table, tree, or graph, basically any collection framework that you're using for your particular language. For example, in Java, you have array list, you have hash table. In IFO, you got also the corresponding types, right? For every programming language, it follows the same principle. A collection class is only meant for the storage and retrieval. For example, it's only meant for the storage and retrieval for the elements. Okay, so let's say for the case of the stack, we actually want to make sure we follow the last in, first out principle. Okay, however, it is not to do with how the elements are manipulated. So that's aspect number one. Okay, so let me just so this is aspect number one. So now for aspect number one, we should really be careful that we only focus on the how the storage and retrieval are done, whereas for the data types, like the type of the elements in the collection, we want to really minimize code duplicates as much as possible. So if you simply compare this slide and previous slide, you see lots of duplicates. That's a very strong sign of poor design. So now how can we change it? This is the principle here. I'm just putting that a little bit informally. So people say your design smells. which is not good, right? If you design smells, if you have to create an almost identical new class, if you consider if you consider string stack versus account stack, they look almost the same except for the element type. So if you got code duplicates, so that means for every stack element you need, so now you got for example, stack of integer, stack of character, stack of person, etc. You have to duplicate a new like an almost identical class. So instead, what you can do, so now we move on to a good practice, which is called generic class. So now we are, as I said before, for this particular lecture, we just want to introduce to you just the idea about how you can write and also use a generic class. And later, once we talk about inheritance and also talk about polymorphism, dynamic binding, etc., we will move on to a little bit more insight into why generic class will be beneficial. But for this lecture here, let's just learn how to use it. Okay. So now the number one principle you have to understand about generic class is we want to parameterize the element type. So what do I really mean by parameterize? So we'll see in this example here. Let me just show you the slide very quickly, and then I'll move on to iPad to actually illustrate to you what's the parameterization process. Let's say we had a class called stack, but now if you only see that over here, the stack, the name is not called stack string or stack account anymore. So we simply just call it stack. And then this is really critical over here. In iPhone, we simply use the square brackets to really hold the parameter name over here. On the other hand, in Java, you simply got an angle bracket, like a less than and greater than sign. So conceptually, they are really the same. You just have to watch out for the syntax. So the G over here is called the type parameter, which means once you declare this G over here, you can actually use that G in anywhere of the class that we're going to define below. Okay, so for example, you can see when we say imp is going to be array of G over here. So the G over here is referring to the G over here. So now think about this G over here at the top over here. That one there is really declaring some parameter. On the other hand, the G over here below is really using that parameter. Okay, I will illustrate to you in just a moment. And then we also got our count, which does not depend on the type of the stack. And also now you can see the top. Again, the G over here is really referring to the G over here at the top, okay, the parameter. And then we also got push. Okay, it's the same. So the parameter, so this is the type of the stack, which and then it's also referring to whatever G it is. So now we're talking about the supplier class. And then we also got pop. Okay, the pop doesn't really depend on that, so that's fine. Okay, so you can see it's quite a bit of change. So let me just show you again what the parameterization process is that we have shown. Okay, again, let's see. We put these two classes that are duplicates of each other side by side and see what the process was to parameterize it. So the idea would be, rather than having two separate classes, right? We got class number one, we got class number two. Rather than having these two classes, we're going to combine them, collapse them into one. Okay, so now let's say we don't worry about this class anymore. In general, just need one. Okay, the way to do it is like this. So we're going to say, rather than being very specific over here, we just simply call it stack. And then we'll simply declare using square brackets. In general, you can declare as many type parameters as possible. But for this case, just make it simple, just declare one. Later on, you will see. Just take one example for you. What would be one example of generic class where you got two generic parameter? Let's say a hash table. In the case of hash table, you need one generic parameter for the key and the other one for the value. But now we just make it simple, just one. So now I'm going to declare G over here. Okay, so now it's very important for you to say this. Okay, it's the parameter for the type of stack, or in general, just any collection. So now the collection is simply just stack, the last in first out collection of stack items. Okay, so now it's really important for you to really appreciate we're doing parameter for the type. Okay, it's pretty much like what do I really mean by parameter? The easiest way for you to recall what a parameter is let's say if I have a function called add, right? If I want to do addition, I want to say I can add any two integers together. So that's why I can simply say I is a parameter, and also j is also another parameter. You can think about the I here is a little bit similar to the g over here. They are simply just being declared that you can use it and you can refer to it. So let's say I and j of type integer. Let's say. Okay, you can think about this is like a parameter, which is a param. And integer over here is the type of the parameter, right? And now once you have declared these two parameters, how would you actually do it? How would you actually implement it? You will simply refer to, for example, result is assigned to I plus j. And now you can think about the I over here is about the use of the parameter. So that's the simplest analogy I can think of to help you. So now you can think about over here, we're just declaring the type parameter g over here. So it's not really to use it. To use it, it has to be within the scope of that particular class. So now this will be the scope of this particular class that we can simply use the g. Okay. So now let's see how we can use it. In this particular case, so now what we used to say very specific about a string type. So now we can simply use g over here. What we used to say very specific about this particular stack, we can also say g. And also the string over here can also be replaced by g. Okay, so this will be the single class that we need over here, just the single class that we need in order to create a count of stack. Excuse me, a stack of accounts and also a stack of string, and also even stack of birthday and etc. We're going to see how exactly. So we only talk about a supplier over here, but we're going to see how as a client, how you can instantiate different kinds of stack classes. Okay. Okay, so now this is about the supplier's point of view. So this is about as the supplier of a generic class. And then it's very important, the g over here, the g over here, the g over here, all of these over here are simply usages of the generic parameter. So we only declare this once, and then we can use that for 3 times, or as many times as you like. Okay, so hopefully there's no confusion about how you can define a generic class. How many generic parameters you want to declare for your class is completely up to you. So 1 is the minimum if you want to make it generic, but you can have as many as you like. Okay. Okay, so of course, if you want to declare more, how would you do it? You would say, for example, g, comma, and then h, and then etc. So it should be separated by comma, just one example. And then what would be the constraint you have for generic parameter? The constraint will be, so it should not clash with, let me just put the constraint over here. So now you can think about the constraint over here. So it should not clash with any existing classes. For example, if I simply declare, let me just give you one example right away, which wouldn't compile. You can also try. If I simply declare by saying class, and then I simply say stack over here, and then over here, rather than declaring something that wouldn't clash, I can declare something that would clash. I can say, for example, string. Because I know pretty well string is already an existing class. So now this would not be a valid parameter. So this will be invalid. Invalid parameter name for type. Okay, just give you one example. You can also think about other example as well. So the only constraint is you cannot give anything that's clashing with other classes, existing classes. Okay, so now let's go back there. Okay, I think for the supply side we're being pretty thorough. So now let's now go on to actually go talk about for the clients. How can you use the generic class as a client? Okay, so this is one example over here. The idea would be to be a client, in order for me to use the stack class, okay, when I declare the variable, when I declare the supplier variable, I need to commit right away what kind of G I need to instantiate to be instantiated into. For example, you can see in the previous case, you can see the G over here from the supplier side. Supplier simply leave this part here like a placeholder. It's simply just open. So the client is required to actually instantiate the G into any existing class, right? From the supplier side, the G cannot clash with any existing class. On the other hand, for clients, they can actually do instantiate G to be some existing class. So that's a distinction you have to make. Okay, let me go back here and see how we can do it. So now, as soon as the clients declare, let's say, instantiate a G over here to be a string, so that means you can imagine that there will be a separate copy of the stack that's created in the following way. So now G will be instantiated by string. And also, every occurrence of the G, that's the usage of the G, right? And we talk about declaration versus the usage of the generic parameter. So now every usage of G will be replaced by string. So now just by declaring this from the client side, you can think about the compiler under the hood is going to create a separate copy of the class, which you don't have to worry. Okay. So now you can think about, so implementation here, it will just be an array of string rather than an array of G, right? So now you can imagine that how can we create a separate copy to ask the compiler to actually create a separate copy if we want this to be an array of account? Well, you simply, as a client, you will say stack of account over here. That's all you got to do. Okay. Okay, similarly, the top will be returning a string as well, and also the push will be returning, also would be taking as an input some string value over here to be pushed. Okay, so now that's about the client. Also, it's not very difficult. You just have to know the process of instantiating G to be some existing type. That's what you have to watch out for. Okay, so now I would like to go over one example with you, but for the case of the account, it will be similar. So now rather than instantiating G into a string like the previous slides, so now we're instantiating G by account, right? It's just a similar instantiation process. And then now every instance of G is going to become account. So now you can think about just by declaring this variable over here, stack of account, and also by declaring the previous variable, stack of string over here. By declaring these two variable using the same stack class, we just instantiate G to be different types. So now implicitly, we are really creating two classes, but we don't have to do them by ourselves. The compiler is going to handle that for us. Okay. You may have actually used generic classes in Java before, but maybe you have never be taught why we can do it. But for now, I want to keep it a little bit more intuitive. Later on, we're going to see more in-depth rationale for why using a generic class. It has to do with casting, instance of, and etc. Okay. Okay, so let's see the final example I would like to do is on the slides, and also I'm going to illustrate on the iPad. We simply just want to see by declaring these two stacks. One is the stack of string, the other one is stack of account. We want to see how the compiler is going to type check your code. That's also important for you as a user of the generic class. So that's something I would like to illustrate to you. Okay, I'm going to let you read the slides, and then I'm going to illustrate on the iPad line by line. So now let's take a look over here. So now we are already talking about a generic stack. So it's a generic. Okay, we already know how to declare the generic stack, right? Again, this is the declaration. Okay, so this is the declaration of the generic parameter. And the pink one over here, so these are all the usage of G. Okay, that's from the supplier side. Okay, so now let's see. So this is the supplier, which is a generic stack. So what we want to see now is this particular clients. And let me just be very careful with the color over here. So we got client, clients. So we got SS, which is going to be a stack of string. And also we got, let's say, let me use orange here, SA. And that one is going to be a stack of accounts. Okay, so now in order to really see how these lines of code will play together, so we have to just implicitly argue this way. Okay, so now for SS, as soon as we declare it to be a string type for every element, is effectively as follows. So now that means this G over here is replaced by just string. I'll say S just for string over here. And now every occurrence of the G over here will be replaced by S. Okay, I'll put S here, S here, S here. Just notice the color. So green is the first declaration of the stack. Okay. On the other hand, the second variable we're declaring here SA. So now this G will be instantiated by account. So now for the orange, I'm just going to put it aside over here. You can see it's A here. So that means it's just another copy of the class over here. So this will be, so now once we instantiate G over here by just A, every occurrence of G will be replaced by A. So this will be A, this will be A. So we are really talking about two different versions of the stack, depending on whether it's SA, whether it's SA, or it is SS that we are talking about. When we talk about SS, we are really talking about this particular instantiation where every occurrence of G is really referring to string. So it's really like a string stack. On the other hand, when we are referring to SA, we are really talking about this particular instantiation where every element type, either return type or input parameter type, is simply an account. So now, having known this, we want to see whether a line will actually compile or not, right? Let's see how we can argue that. Let's say line number 6, when we say ss.push A over here, okay? So now, first of all, since we know ss is now referring to this particular variable, so now every element type is simply a string. So now we know we're talking about the green version. So when you talk about the green version here, so that will be the push. And then when we go to the push, so the green version is expecting a string. Is A a string? It is a string. So this will compile. Not a problem, right? Also, you can execute it using a test and it will also be correct. Let's see another one here. The second one here, you can see we are still using, so line number 7, we are still referring to SS over here. So that means the push that we are talking about is still this particular version over here. It's expecting a string. But we are giving an anonymous object of type accounts. Can we pass an account objects to be pushed into a string stack? The answer is no. So that's why this line over here would not compile. Okay, hopefully you can see the reasoning here. So I'm just trying to make it very visual over here so you can see the intuition. How exactly you build your mental model, of course, is up to you, but I think that this is one way to actually build your mental model for checking the consistency of usage of different generic stacks. Okay, you just have to know exactly what types have been instantiated into either string or its account. Okay, let's see another example over here. Let's say we see line number 8. So now here we talk about SS over here. So now we talk about the top. So it would be the green one still. So if you go to the top query over here, it's going to return a string value. Okay, so we know that the right hand side over here is going to be a string. And now the left hand side is simply just a string as well. So this is compatible. So this is okay. On the other hand, when we are calling the saying ss.top, again, it's going to return a string, right? Over here, the string. And then, however, the A over here, you can see that one there is actually an account. Can you assign a string into account? No, you cannot. Apparently, they are not really compatible with each other. So this will be actually not compilable. Okay, so now from these 4 lines, we basically just talk about how you can use SS stack, which has been instantiated for its member type to be a string. So now the rest of the code will be from 10 to 13 over here, where we're just going to use the SA. Let me just do one of them for you, and then you can do the rest just similarly. Okay, let's see the first one. If we try to do, let's say, SA over here, you can see SA. So now it's really referring to the SA over here. So now every G has been instantiated by account already. So now what about the push? You can see for the push, it's going to be the orange version. So the push, the same block of code, but now the expecting argument type would be account. So now the argument is indeed an account object over here, right? So this will be okay. So let me just highlight 2 lines for you as my conclusion. If you look at line number 7 over here, and also line number 10 over here, okay, you can see basically over here, the postfix after the dot. When we say push some account object over here, and also we say push the same account object over here. Well, not the same type. However, this line does not compile, but this line does compile. Why the difference? The reason is the context object is different. In this case over here, the context object is simply SS, where we already instantiated the parameter, the generic parameter to be a string. So that means every element in the stack should be a string. So that's why account is incompatible. On the other hand, for the second one, that is okay. You can see for SA over here, the G has been instantiated by account. So that's why account object here is compatible. Okay. So now that's just one example for you to see the contrast. Let me highlight just 2 more lines. You can think about them. What about this line over here versus this line over here? Oh, sorry. And this line over here. Think about why one line would actually compile, but the other one wouldn't, right? You can see this, these 2 lines look almost the same, the blue one, except that the context objects are actually different, okay? But you want to see why. Okay, so that's about the example I want to go over in detail with you. So again, this lecture here is meant to be very short, just for this one here, because we just want to see how you can define a generic class as a supplier and how you can use the generic class as a client. And as a client, you have to be sure which instantiation you're really using. In this case, either SS or SA. You have to be careful to the details. Okay, let me just go back to the slides. I think that's about the example I've gone through with you. You can definitely look at that in more detail. Try to create your own example as well if you wish. Okay, so these are just some example, just some explanation which I have gone through already. Okay, so that's about the end of this lecture here. Before we move on to the next topic, please make sure you know at least at the user level, at the application level, how you can define a generic class and how you can use a generic class before you move on.